Hi friends, I'm your food in CS147. I'm going to explain the seventh experiment of compiler lab, that is its implementation of predictive parser. A predictive parser is a top-down parser that recursively parses the expression, and it is a left LL parser. And now we'll see for the implementation of predictive parser. So at first we are defining the size, num, keyword, id, all above the main, and then we are initializing lexemes, buffer, all as an array, character array. Then we have initialized last character, last entry, token value, line number and look ahead as integer values. Then we are creating a structure known as entry for checking the entry, so that there we have character, lex pointer and integer token, and we are initializing a symbol table array of size 100. In this struct entry, we are mentioning the keywords that are used here. So some of the keywords like if, else, double, character, struct, all are initialized as keywords. Then if we are printing, we are also having a function known as error message, that is to print error if any error occurs. And in we have the function known as lookup. In lookup we have an integer k, and we are checking for the entries that are given, and in a for loop we are checking the last entry that is made. We are initializing it to the integer value last entry, and in this last entry we are comparing it, and we are entering the lex pointers into the symbol table, and if it is equal to 0 then return k or return 0. Then next one is integer insert. In integer insert we have length equal to string length of s, and if last entry plus 1 is equal to maximum, then the symbol table is full. That is, if the last entry that is made is equals maximum is initialized already, and if it is equal to max, then symbol table is full. Likewise, if the last character from length plus 1 that is maximum, then this lexemes array is full, so any entry cannot be made to that. Then symbol table dot last entry dot token is equal to tok, tok, and symbol table last entry lex pointer is known as lexemes. And we are making a string copy of symbol tables last entry with lex pointer and s. Then we are returning the last entry. Then in integer lexer we are going to the get, we are initializing t, and in t we are going to the get the character, and if in the character we are checking the if it is in tab or if it is next line, and else if it's digit, then we are going to check that digit, and we are checking whether it is a token value or it is a number. And if the character that is getting in is greater than the size, then the compiler error will be printed. And then if value equal to 0, then we are inserting the value into the buffer comma id, and token value equal to value, and return symbol table value dot token. So the value symbol table is returned. Then if it is end of file, then return done, else token value equal to none. Then void match. Now we are going to match it. Till now we have entered the things, and now we are going to match it. If look ahead equal to t, then look ahead equal to a lexer. We are calling the lexer function, or else we are printing an error message. Then for void display, if the entered character t is plus, minus, star or a division symbol, then it's arithmetic operators, or else if it is equal to num, that is number. If it is an id, then it is an identifier, else then it is a token. Then for void f, we are inside the void f we have a void e, that is switch case for look ahead. If we have an open parenthesis, then we have to match that open parenthesis with an closed parenthesis, and if you are having number, then that number is displayed as a token value. and we are matching it with a number. And if you have the ID, then that ID is displays as token value, and we are matching it with the ID. Or else in another else anything than this, then it's an error, syntax error. And now for void t, again we are matching with look ahead, and if the case is star, then we are matching it with look ahead and calling the function f and display t comma none. And if it is division also, the same thing is done and it is displayed. And for void e, we have the cases for plus and minus, and this plus and minus we are matching it with the t. This look aheads are matching with, if it is t equal to a look ahead, then we are matching the look ahead and the calling the other functions like t, and it will be printed. Then void parser, we are going for the then if look ahead equal to lecture, while look ahead not equal to done, we are calling e function, and we are matching it with semicolons. And in main function we are just printing the outputs, that is we are going to enter the they ask us to enter the expression, so we are going to enter the expression. And if we press control and z, then it terminates, and they are calling the function parser. And from the function void parser, all the expression accordingly what we are entering, accordingly the different functions will be called, and the top down passing of that expression that we have entered will be happened by this. Now we'll see the output. So this is a design parser, so we are asked us to enter an expression. So a plus c star d. So now a is an identifier, c is identifier, d is an identifier, and star and plus they are operators. Now if we enter 5 plus 9, then 5 is number and 9 is also number. Likewise if we enter 34 into d, then we are getting that plus is it is slow. Now if we are entering a plus b star 6, then now a is an identifier, b is an identifier, 6 is number, and star and plus is arithmetic operations. And if we are not specifying the semicolon, it will be, the operator will not be printed. By this the parser is completed. Thank you for watching.